So, hello everyone. Today I am starting with a new part, with a new module, that is the propositional logic. First, propositional logic starts with this proposition or statement. It is clearly mentioned there. It is clearly mentioned there that the proposition or statement is what? Look at that, the definition: a declarative sentence which is either true or false. Look at, also we are mentioning here an example which is written that your name is Ankita. Either it is true or false. This type of statement or this type of sentence, we call it a proposition or statement, and we denote it by PQ1. Okay. Now look at this example. P is a proposition. We tell it a proposition. A plus B equal to 3 for all AB. Here P is not a proposition because for some AB it is true, but some AB it is false. It cannot be happen as a both time it is false or true. Either it is false or it can be true. Truth value of a proposition, the truth value, that means true value and the false value of a proposition, called the truth value of the proposition. Look at that, how we construct the table. P, true and false. This is a table, and this is the table for the one proposition. Next, we go to the logical connectives or operators. Okay. First one is called the conjunction and second one is called the disjunction. This is the sign of conjunction. It is looks like, and this is the sign of disjunction. Look at that, the truth table of conjunction. If both are 1, then we call it 1. And if any one of its value is true, then it is true for the disjunction. So looks like the similar of intersection are and or. If you transfer it into the logic gate or the Boolean algebra, so we will denote it by 1, 0. True means 1 and false means it is 0. So I think this part is clear, what is called the conjunction and what is called the disjunction. Look at that, conjunction is and disjunction is or, either A or B, but it is and. If both P and Q holds, then it is true. That's like we are do it in the conjunction. Next, here we construct a table which is for 3 proposition. 3 proposition, look at that PQR. There is a convention to write it down. First column we write down 4 true, then 4 false. Next one, Q, we will write down 2 true, then 2 false. 2 true value, then 2 false. R, true, false, true, false. Then we will find out the conjunction and disjunction. Okay. So how many entries we are finding here? We are finding the entries. We are finding the entries up to 2 to the power 3. Look at the 2 to the power 3. 8 entries are there. Next is the negation operator or negation connectives on a statement. Negation means if P is true, then negation P is false. If it is false, then it is true. Simple as the NOT gate. Okay, not P. Next one. Next one, look at that. This is called the conditional connectives. This is called the conditional connective. First one is called the P implies Q. That is, if P holds, then Q is also holds. I am taking here a example, basic example. You can say it as a real example. Ankita work hard. Ankita comes first in the 4th sem. So this is true. Ankita work hard. That's why Ankita comes first in the examination. That is true. Ankita works hard, but he didn't get the first position or get the better marks in the examination. So this only the false. If the first one true, next one false, this only the false. Otherwise, both cases we will get the true value. True, true, that is also implications true. False, true, that is also true. False, false, this is obviously true. Ankita doesn't pay attention or doesn't works hard, then obviously he will not get the better result in the examination. That is obviously true. These implications are Correct. So this is the truth table of the implications. Okay. Next, we will go to the next slide, that is the converse. Converse of this, P implies Q, this converse is Q implies P. Then what will be the truth table of this? This will be the truth table. This is false, this is true, this is also true, this is true, this is false, this also false. So converse of P implies Q is the Q implies P. Next, we go to the next slide, that is the contrapositive. Contrapositive means if it is implications for your short purpose note, we will write it down. P implies Q implications, Q implies P converse. Contrapositive means not Q implies not P. Here we write down the not Q implies not P. First, you have to write down another two columns, that is not P, not Q. Then you can find it out this. And look at that, P implies Q and not Q implies not P. Both this table are same. This we are called, in the later slide, you will see that we call it a logical equivalence. Achha. What is called the inverse? Not P implies not Q. This is called the inverse. And if you see that this and these two are the logical equivalence. These two are the logical equivalence and these two are the logical equivalence. Okay. Contrapositive. And next one is the inverse. Inverse is logically equivalent to converse. Implications is logically equivalent to contrapositive. I think up to this part, there is no other doubts. Again, I will go from the first slide, what is called the propositional logic or statement. Next, we go for the logical connectives, that is conjunction, disjunction. Next one, we will draw or construct a table with three propositional or the statement. Next is the negation. Next, conditional connectives, implications, converse, contrapositive, inverse, right? Next, we go to the biconditional proposition. Bicondition is just similar like the condition if and only if. Okay, P implies Q, then Q is also implies P. So PQ, we write it down. Double implies mean if both are same, they not only true. Otherwise, if any one is false, then it is false. This is the biconditional proposition. Okay. Now the propositional formula or statement form. It is simple like the, what we write down, fx equal to cos x. Here we write down fx equal to sin x. Now x is changed by the statement. Now we will use in the terms of x, not the variable, simple. It is now the proposition. So f of p comma q, here we write it down in this way. F of p comma q, this is also a propositional formula. If we only used one proposition, this is called the simple propositional formula. If you use the 2, 3, 4, whatever the proposition you use in your formula, then it is called the composition propositional formula. Next, we will see that this has given the propositional formula. So what will be the truth table of this formula? So if you find out the truth table, so this is the truth table. Okay. And what is the pattern for writing? If two propositions we have given. So first we, how many inputs are there? 2 to the power 2. First we write down 2t, then 2f, then tf, tf. If it is 3 propositions, so 2 to the power 3, 8. First we write down 4 true, 4 false, then 2, 2, 2, 2. Then 1, 1, 1, 1, it is divided. Clear? So here we solve a truth table of this formula. This is asked in the examination also, say how to find out the truth table of some formulas. Now, tautology and contradiction. What is called the tautology and contradiction? Suppose you have given a propositional formula like that. Here it is given in this way. Next, we will find out the propositional table. If in the last line, or last column, you are getting all true values. This is called the tautology. For this problem, all the entries in the last column is true. That's why it is a tautology. If you are taking the negation, that will becomes the contradiction. Look at the example. A propositional formula is called a contradiction if it assumes only the truth value f, that is false value it's are taking, just like the previous one. Now, it is your homework, you can say. Also, I will give you a questions like that. Find out the truth table of this. This truth table you have to find out, or stay connected and find out the truth table of it. And if you get the answer, you will give me in the comment box also.